Hello. Sorry this is a bit late. I actually recorded a video last night, but I didn't like it that much. I think this explanation will be much clearer. Okay, so we're going to start with, instead of 3D, we're going to turn everything back to 1D, just for simplicity's sake, but as you can imagine, these wouldn't be that different. We'll call the system S, and then we'll call the below system S prime. And S prime, this one is moving at some velocity v, okay, to the right. And this is the x-axis. This is the x prime axis. At t equals to 0 and t prime equals to 0, they are on top of each other. Okay, I drew them separately, but imagine they're on top of each other. And as soon as the clock starts, the x prime starts running, or the s prime, the system s prime, start running to the right. Okay, as when they start running, at the same time, they shine a light bulb. Okay, so as soon as the time starts, s prime starts moving, and both light bulbs turn on. So how can we describe the situation? Well, remember, so the light circle created has radius r, where r equals to ct and r prime equals to ct prime. Okay, because there are two light circles, so the light circle in S and the light circle in S prime. Okay, so the light circle in S is the above, the light circle in S prime is the below. Okay, now we can write r simply as square root of x prime. Okay, that's just a changing x. So in this case, in 1D case, this is just x technically. So this equals to x, which also equals to r, by the way. And this will be more important in 2D. This becomes x squared plus y squared plus z squared all square root. That will be r. In 1D, it's just this loner. Okay, this equals to ct. Now I'm going to square both sides. So x squared equals to c squared t squared. Similarly, we would have x prime squared equals to c squared t prime squared. Okay, now this is the part where I think I didn't explain things well. So what you want to do is to transform one into the other. Okay? Why? Well, because you want to describe different positions in different frames using one transformation. Now, so you want to get from this to this, okay? That's the goal. So let's call this 2 and call this 1. So you want to transform 2 into 1. That is the goal. And what is an obvious attempt? Well, the most obvious attempt to transform 2 into 1 is to assume, now I'm using the word assume, so attempt is to assume, I think I spelled attempt wrong. I don't know. Assume Galilean transformation. Okay, you assume it's correct. Now, again, like we noted in class, GT doesn't account for the effect that C is a constant, okay? But you can obviously assume that Galilean transformation works, okay? In which this implies x prime equals to x minus vt. Okay? You can assume this is true. There's no one stopping you from doing that. But what we'll see is that you need to, this assumption leads to some adjustment, okay? This assumption is not correct. That's what we'll see. Okay, so we'll substitute everything in there. So we have x minus vt squared equals to c squared t prime squared. So, and you would expand both sides, x squared minus 2x vt plus v squared t squared equals to c squared t prime squared. Okay, now, what is wrong with this? Or what else do we need to do? Well, we transformed x, okay, which is fine. Now we need to transform t. Because to go from 2 to 1, you not only need to get x prime into x, you also need to get t prime into t. So you also need to make some adjustments to t. Let's call that this, t prime equals to t minus vt. Fx, sorry. Okay, and f is a constant. So this takes on the form of Galilean transformation. Okay, this is the form of Galilean transformation. It looks similar, the two. But in this case, we don't know what f is. Okay, I want to find some f that makes this work. Well, the most obvious trace of f is one that cancels out this. Okay, so this is 2x vt, and then you can substitute this in there, c squared t minus fx squared. Okay, and the most obvious, most convenient choice, not obvious, most convenient choice of f is one that cancels out this ugly thing. Okay, so this gives you f equals to negative v over c squared. Okay, so what are you left with? You're left with this x squared minus 2x vt plus v squared t squared equals to c squared t squared minus 2x vt plus v squared over c squared x squared. I think that's correct. You can check my algebra, but I think so far haven't made any mistakes yet. Yeah. Okay. And these two things cancel out. Okay. And I'm gonna move this to the right. I move this to the left. Okay. So I'm left with x squared. Okay. I'm skipping a few steps here. 1 minus v squared over c squared. Hopefully you can still follow me. Equals to, I move this to the right. Take out a t squared and a c squared. T squared c squared. 1 minus v squared over c squared. Okay, now here's the important thing. Remember, our goal was to transform this into this. And we assumed the transformation is Galilean transformation. But you see, you're left with these two extra terms. Okay? So how do you get from here to here? Well, if you tweak your assumption to not this, but rather your new assumption, we can call this Lorentz transformation, because GT is Galilean transformation, Lorentz transformation. X prime doesn't equal to that, but rather x prime equals to x minus vt over square root of 1 minus v squared over c squared. If you assume this and you carry out all the algebra, so here you would replace this with the new LT, and you carry out all the algebra, you will see that these two terms cancel out. This term and this term cancel out. Okay, so this is why this is the correct transformation. So if you go ahead with the normal Galilean transformation, you're left with these two extra terms. But if you change your assumption to Lorentz transformation, which is this form, then these two terms cancel out. You successfully transform from 2 to 1. Okay, so that's how you transform x prime. And for t prime, you can check the algebra yourself, but this turns out to be t minus v x over c squared all over square root 1 minus v squared over c squared. Okay, this is, well, the above is just t minus fx, and f we found here. Okay, so I hope this clears things up a bit. And just one more note, we call gamma the Lorentz factor, and we call this, where we define this to be this whole thing, so that so I guess more conventionally it's written as x prime equals to gamma x minus vt. Similarly, t prime equals to gamma t minus v over c squared x. Okay, I hope this clears things up a bit.